All right, so what I want to do is for you folks that were not in class on Friday is to give you what we went over on partial fraction decomposition. It looks like I'm going to try to make this into 3 short movies. I've got new equipment here, so it's going to be a little awkward as I get used to it, but I think I've got a handle on it, so let's proceed. So the whole basis for what partial fractions, partial fraction decomposition entails is to make something complicated that's a rational expression into something, break it down into component parts that are a little more simple. If you think back to Algebra 2, when we did the rational functions section, we basically would take two simpler rational functions, rational fractions, and we would find a common denominator, and they would either be a sum or a difference, and we'd take that common denominator and put those two things together in a manner that we could just, consider to be one final combined simplified rational expression. Well, what we're going to do here is take that final simplified rational expression that's the combination of the other two and break it back down into the original component parts of whatever sum or difference might have been what we started with. The whole thinking process being that when you get to calculus, it may be that that sort of thing will make some of your calculus manipulations go a lot easier than if you just started with the complicated original thing. So if you look on page 26, we've got this problem. We'll just start out with x plus 7 over x squared minus x minus 6. And step 1 to doing this is to take your denominator and to factor it. So that'll factor into x minus 3 times x plus 2. And that's what we're going to do. We'll just go ahead and break this down. Here's one component part with one of those factors, x minus 3, and then plus, here's the other component part, and that'll be over x plus 2. And don't know what those numerators are, so we'll just go ahead and start with that being a, and this will be b. And just imagine that if we got a common denominator, we would be missing an x minus 3 over here. So we would need to multiply the top and the bottom by that. Over here, we're missing an x plus 2. We would then multiply numerator and denominator by x plus 2. Then we would be able to put the two together under a common denominator, and it should reestablish the original numerator. So now what to do with all of this? Well, we're going to go ahead and clear out the fractions. So we're just going to multiply everything by x minus 3 times x plus 2. And we'll do that to all three. So x minus 3 times x plus 2. And x minus 3 times x plus 2. All right, so what happens? Over here, this will completely cancel out with this, and we'll be left with x plus 7. And we'll only be able to cancel out a part of this, so we'll be left with these two pieces that will form your expression a times x plus 2. And then over here, we'll be able to cancel out an x plus 2, and that'll leave us with b times the quantity x minus 3. All right, and looking at that, it looks a little unpromising because we have one equation with 3 unknowns, which, no, that's not what we normally would expect. But if you look closely, we have an x in every particular term here. There's x here, x here, x here. So we can actually pick whatever value for x that we want. And if we pick it strategically such that it'll make one of these terms go to 0, then we can find the value of the other one. So let's just let x equal negative 2. that'll make this term go to 0, and we can solve for b. So negative 2 plus 7 equals, all right, plug the negative 2 in, you get 0a. And if we plug negative 2 in here, we'll have plus b times negative 2 minus 3. And putting it all together, or simplifying, we'll get 5 equals negative 5b. Or divide, and then you get b equals negative 1. So that's kind of halfway. So at this point, maybe we could eliminate the b term over here, or the b part of the expression, and solve for a. So strategically, let's let x equal 3, because that'll force that to go to 0. So plugging in for x, we'll have 3 plus 7 equals, all right, that'll be a times the quantity 3 plus 2. And then if we put a 3 in here, that's 3 minus 3, or 0, so that'll be plus 0b. Easy peasy, all right? So we get 10 equals 5a, or we'll just say that a is equal to 2. All right, so we've got everything figured out, and we can just go ahead and report the partial fraction decomposition. So x plus 7 over x squared minus x minus 6 equals, well, let's see, a we determined to be 2 over x minus 3 plus b was negative 1 over x plus 2. All right, mission accomplished. So, and if you want, you can go ahead and just write this as minus 1 over x plus 2. Either way is fine. So let's suspend here, and I will try to shut this down, and we'll go on to the second one.